Welcome back to the stream, everyone. I'm gonna get back to things that matter, like doing CAD for robots that follow my amazing cat around. Cat butt. This cat comes equipped with an emergency stop button in case the cat becomes too much cat for us to handle. It's important to note that it doesn't actually stop the cat, it just disconnects us from the ability to experience the cat over the internet, potentially also causing data loss. Nice and toasty over here. Tico seems to be pretty into the temperature. Are you sniffing at that button, Tuco? You don't push it. You know you don't want to push it. That would be terrible. Maybe I can already mount this on the side of something. It's just if I stick it like right below where it is, that's the door, which has to move. I guess I could stick it. How much cable do I have? Not very much slack right now. Tuco, is this what you wanted? This is something completely different. This is a bearing press. Oh geez, which red button does my cat prefer? I think he prefers this red button. So this is actually something we designed in a previous stream. This is a little bearing press where you put a 606 like skate bearing on the end. And then you can use this in your palm to just press it into something. I'm worried about this button now. Let me put the button on this side. No, Tuco, this is my button. This is not your button. Don't bite the button. There we go. We're still online. I think we might be fine. Assuming that tape has any chance of holding. Tuco, are you mad that I moved your button or appreciative that I gave you more space? Would you rather have this button? Duke. What a tiger. This guy's a little bit rambunctious around wires sometimes, which is why these are going to eventually be covered up. Tuco, is this like a giant bolt? You know this is a hand tool, right? Not a mouth tool. That is kind of a giant bolt. Can I pull myself away from this to get back to the desk and get some work done? I can see some people talking in the chat, but it's too far away for me to read from over here. Hey Duke, you want to migrate to this side for a bit? Who's that little tiger? Aw. Oh, Mikey in chat asks, how old is Tuco now? I think he's a little under 3 years at this point. I don't know exactly when he was born, but somewhere between like 2 and 3 years. Alright, I think maybe the cat's in cleaning mode and we can go into CAD mode. Capstans? More like cat stands. Yeah, I appreciate that. So speaking of cat stands, we've got a desk full of equipment here that we've assembled for our winch control robot. So part of the context here, and if you haven't noticed it yet, I'll direct you to the little topic line. I guess it would be that way. So I've got this thing at the top of the video which I've been trying to keep up to date with, kind of the stream of, well, what are we doing now and why should we care about this particular thing? Because often the work on this channel gets really, really deep and involved in one particular tiny part of something that's bigger. And so when I'm editing a video, I can use the editing itself to try to give, a reasonable amount of weight to the different components and to try to keep the narrative focused on the overall goals if it goes really deep into one of those holes. But with the streams, I can't always necessarily do that, with what I'm saying or doing. Otherwise, we'd be doing recaps constantly. So for that, it seemed like maybe a good assistance to have that text up there. So to that end, this is part of my project to have, kind of a viewer-controlled camera robot that hovers around on 4 of these winches that'll go in the corners of the room. And the idea is to keep the robot near the ground so that it's easy to work on, but then just have a pulley that's way up near the ceiling. Take advantage of the high ceilings here and have some robot that can kind of hover around quietly and observe the cat, and potentially either this robot or something related that's mounted in the room can toss bolts for him or interact with him in other ways so that people can, go back and forth. So, yeah, so the goal here is turn my cat into the first internet-connected cat cyborg, basically, without making him uncomfortable at all. So the robot's going to be quiet. It'll keep out of his face. I don't want him to have to wear anything for tracking, so the tracking will all either be based on computer vision or thermal vision, or just having people in the audience control the robot directly, or some combination of those. There's enough space here to mount, let me switch to the camera and just show you a little bit about the space here. Because part of why I'm doing this project is that Tuco is a really unique cat and I want more people to be able to interact with him. Part of why I'm doing this project is that this is a unique space and it seems like this is some place that where I can kind of open it up to the internet for some large portion of the time and let people interact with the cat, and where there's also a good amount of space for the robot to hover around, and I have fast internet so I can stream it all the time. So yeah, if we get a bit of a broader view here, try to put the camera back here. So that's the rack Tuco's sitting on. This is the desk I've been filming from. And then you can see this place just goes up. So it's pretty amazing here, and that's one of the reasons why I think this would be a really great robot here. Because, you know, for the first few tests, I'm not going to bother climbing all the way up there to attach a pulley, but eventually that would be a great place to just stick the pulleys all the way in the corner of the room. So, like looping the camera around all the way. Yeah. So you can also see the room is basically a box. So that's why there would be 4 winch bots. Each one would be attached to a pulley somewhere in one of these top corners of the kind of main space here. And then the actual robots could be located somewhere along the wall where it's just easy to maintain them. And then all the actual processing can be done inside the rack, but I need at least like a Raspberry Pi 3 probably, or Raspberry Pi 2 rather, on the actual bot to collect data from a depth camera. So that's pretty much what this is for. If we go back to the desk, this is most of the hardware that I've massed together for the individual winch bots here. So these are the spools in a few different stages of assembly. This is one which is pretty much entirely put together, but is an older version. So it's designed, oh, I should be recording this. So here on the desk we have all the hardware that I've massed together so far for the individual winch bots. Here you can see one of the spools. This is the most assembled, but it's designed for a motor with a smaller diameter shaft, which turned out to be way underpowered for this. So this is the new motor. These are 24 volt, 200 RPM max, so the motor will carry the robot pretty swiftly across the room with this diameter of spool, even if it's only partially full. But it has enough torque still that I think it'll be able to. I think I'm targeting the limiting or the kind of weak point here at being the 5 kilogram rating on the load cells that I'm using to measure the force. So I kind of roughly sized the motor based on the diameters I expected and that 5 kilograms. So I forget what the actual like stall torque of these motors is rated at, but it was something in the right neighborhood. And this is, I think this is a worm gear drive, although if you get it turning just right, you can actually back drive it a little bit. So it's not great at holding, but I think it's still fine enough. Like it will, if you do get it into a state where it's back driving, the robot will still fall pretty slowly because it doesn't back drive very efficiently. And that is only an issue if that's only an issue really if the robot is heavy enough to hurt someone by just falling, which I'm going to try to make it not be. And it's only an issue if the motor controller just abruptly stops, which it could, but it won't do during normal operation. So you need to plan for it for safety, but yeah. Normally these do not back drive. So I think an axis that isn't already moving will have a tough time starting moving just because of the robot's weight. So anyway, these are nice motors. These run on 24 volts. I got some of these little motor controller breakouts. These are L298s from ST, and I just found these cheap breakout boards on eBay. And they seem all right. They have, it looks like this is a 7805 regulator, which is kind of an inefficient way of getting local power, but hopefully it doesn't need very much current. And a couple of big input capacitors here. Maybe not the best design, but it should do. Bunch of blocking diodes on either side. So let's get a closer view of that. So yeah, these are the motor drivers I'm planning on using for the winches. These L298 boards. These are pretty inexpensive. I think each of these breakouts was just a few dollars. Then we've got these. So that's the drive side. We've got a big spool, we've got a motor with a gearbox, an L298. This all runs on 24 volts. I haven't actually decided on a power supply yet, so that might be one thing we have to do at some point for the CAD, is to figure out what kind of power supply we're going with and how big it's going to be. I have two 24 volt power supplies here that neither of them is probably quite right. I have some of these really small, kind of maybe, this is like a brand I haven't really heard of, so I don't know if this is really reliable. We might want to open one and look at it for safety, since it doesn't have like a UL rating or anything. So this might also just be sketchy enough that you would want to avoid it if it doesn't have a UL rating. These are Weihao brand. Input, universal input, 100 to 120, 200 to 240. Output 24 volts at 1.1 amps, which I think is going to be pretty underpowered for this. I think we are going to want at least like 3 amps or something for these, but we should measure the stall current of the motors to make sure. But yeah, we have these. Probably aren't going to use them. We might take them apart to see how safe they are, but it's an option. I also have this monster. This is a power supply from Meanwell. This is a spare for the power supply that I got to run a bunch of audio amplifiers in an art installation a while ago. So I have another one of those that's still in the project, but this was my backup. So unused, but we could use it. This is Meanwell, which is a really nice brand. These I would expect to be pretty reliable. This is CE certification. And this one's 24 volts at 6.5 amps, which is probably more than we need. We should measure the motor current, but I think this is a lot more than we actually need, especially continuously. Robert says this has a fake CE mark. Is this the fake one or the real one? I forget the really subtle difference. I thought the spacing was wider on the fake one. I mean, in any case, the Meanwell power supplies are like not that expensive, but they're definitely not bargain basement. They are generally respected as being a pretty reliable design, but of course we could take this one apart and take a closer look. Looks like there's a generous amount of spacing in there. Nice big toroid. Components on the left there are gooped down. Those look like power resistors with elastic. Oh, Robert was saying the fake CE mark was on the other power supply. Let's compare them side by side. Oh yeah, so I guess the fake one is closer together. The Weihao logo definitely seems to be trying to look like Meanwell, doesn't it? They even use a similar labeling scheme here. So yeah, the one on the bottom I would not necessarily trust without looking at it pretty closely. The one on the top I probably would trust without looking at it, although looking at it would be, certainly prudent if you were going to use this in a bunch. Yeah, I'm not just going to open these and like rant about the electrolytics. That's silly. That gets old pretty quickly. Oh, okay, so that's helpful. So Physics Dude in chat says the Amazon listing for those L298 breakout says please use an external 5-volt logic supply when using more than 12 volts driving voltage. That sounds about right. I was not going to expect that little 7805 to do that well with 24 volts, so it's good to know that they're warning me about that too. Well, that's fine then. I was planning on using some buck converters to power the microcontroller on here, so I'm sure I'll have some extra 5-volt power to give to the motor controllers. So for those buck converters, I realized I don't actually have any spares in my shop because I got a bunch from Adafruit a little while ago, and then I used them, I think, in a bunch of different things, and I don't think I have any spare right this moment. But, let's see. Oh man, I have this very confusing computer situation going on. Come on, switcher. Oh, right. This button. Yeah, this is the Mac demo machine connected to my editing machine, which currently is still having problems with display, which is then recording this machine. So I just wanted to make sure the recording was working. I think I had everything set up on the Windows machine. should maybe get an IR repeater thingy for this. Oh, interesting. Whisperfist on chat says they recently saw a DC-DC converter module from China burst into flames before their eyes. And I'm curious what that would have been caused by. So the one I think I went looking around just to see where these come from, and so I think these are the ones that I got from Adafruit a while ago. I think they probably still sell them. Let's see what you can find these for on Adafruit, or what kind of DC-DC converters Adafruit has too. Shop. I think this would just be UBEC. Yeah, I think these are similar. And looking at these, they're pretty straightforward design. Like, they're not designed for high current, but, you know, so it's output 5 volts at 3 amps, but that's plenty to run a microcontroller and a couple of motor drivers. So, I mean, yeah, there are a lot of ways to fail at DC-DC converter. You can certainly fail such that the output just gets the full input voltage. You know, this is the capacitor and input's rated for 50 volts, so it's not like they are writing that super close to the rating. I know I said I wasn't going to talk about electrolytics, but the voltage rating seems relevant. Yeah, so there's this. I don't know if it's exactly the same. These seem similar. I got a couple of these recently too to compare them. These are really cheap, $2 each. So I figure, you know, if these are fine, we could use something like these. Otherwise, I'm sure there are other DC-DC converter boards you can get that are like maybe more like featureful, but probably more expensive. But anyway, something like this will do fine, and it takes up so little space that I haven't really thought so much about the design. So the power supply is going to be something probably in between those two modules for 24 volts, which will drive the motors, and then I'll have like an auxiliary 5 volts, which will probably just be a step down from the 24. Although if we find an all-in-one power supply that gives us 5 volts and 24, we could use that. So speaking of shopping, I haven't actually looked for a 24 volt supply that'll do. One thing we need in order to get that is to look at the stall current on the motors. My current benchtop supply actually will not run these motors at full power, but I have a sketchy switcher that maybe will. I mean, I also have this mean well, which is clearly overkill, and we could just stick a current meter in there, so maybe that's the safest thing to do. So I might save that for a different stream because I was kind of in the mood to do CAD this time, but that's kind of a blocker before we know exactly what kind of power supply to get, is I need to test the motor, or we just find a good estimate for its current, and then reserve enough space for the right kind of power supply. Since this is probably going to be bigger than the one we actually need. Yeah, Dr. Toon says buck converters can easily fail, so output equals input. Yeah, for sure. Yeah, I mean, in this system, worst case with that is that the, well, if the DC-DC converter fails, it blows up the microcontroller and the motor driver, and you hope the motor driver doesn't fail on, but if it does, then it just starts running the motor at full speed, and then you have to like hit the physical e-stop on that box. So that would not be good. Decap. Yeah, I'm curious. Yeah, you know, this has piqued my curiosity. Let's actually just do a quick measurement on the motor so that we know what to expect and we can think about the power supply. Because even if we're not going to pick that out right away, I'd kind of like to start thinking about that in the back of my mind. So, here's the motor. To test this, I'm probably going to want to clamp this somehow, which seems a little scary. Like, I could try, well, I could also try just putting it under a decent amount of friction load using one of these plates. That might be safer than actually doing it into all-out stall. So, but let's grab another power supply. Well, this is a good power supply to use. I guess what I mean is we need an AC cable and just a current meter, and then we should be able to use this to do a test with the motor. Oh, use this. This is really sturdy looking. I'm also a little worried that if I use the normal 10 amp meter setting on my Fluke, that this motor's inrush might pop the fuse on there. So it might be safer to use a clamp-on meter. So I've got a mains lead here that I actually liberated this from one of the rack power distribution units because it came with this really long cord and I didn't need nearly that much length in the rack, so I just cut it and re-terminated the plug. I can find my wire strippers, then we can just hook this up to the power supply. Hey, Tuco. Did you see something to hunt? Yeah, Dr. Toon reminds me that the Fluke fuses are expensive. Yeah, I think the clamp-on meter is safer here. Mike's Electric Stuff says, definitely put a poly fuse in the 24-volt supply to the DC-DC to reduce the chance of being on fire. Yeah, that's really good advice. Yeah, a poly fuse is actually a really good solution for that because if you do just start pumping 24 volts into the logic, you'll probably destroy it pretty quickly, but it'll fail in a mode where it just shorts itself out and it'll just draw more and more current. So you want the poly fuse to trip so that it just, you know, fails at being a microcontroller instead of like succeeds at being a fire. So I'm trying not to actually nick any of the interior conductors here by just gently cutting the exterior conductor and then pulling it until I get what I want. Where did Tuco go? He rushed over to the window like there was something he really needed to eat over there. He's probably being cute. I should get the cat cam on him. Why is that wire so tangled? Alrighty, Tuco. I just got it aimed. This is why we need more efficient robots for this sort of thing. Almost got this installation off. This wire is so long. It probably shouldn't be this long. Oh, interesting. Mike's guess is that this motor stall current is going to be way more than the Meanwell's trip point or the 6 amp rating. Yeah. Well, I think maybe I'll start by not just outright stalling it because I imagine the stall torque of this thing is pretty gnarly and I'm not even really sure I want to try to effectively clamp it to the point where I can safely stall it at this point. But I'm curious of at least getting a ballpark for how much to expect it to run when I'm providing it with, you know, a decent amount of resistance on the wheel here. So the first test I do might not be that scientific, but I'd like to get at least just like a ballpark figure. But I don't know, maybe it turns out I do need a giant power supply for each one of these winch bots, which would be a little annoying. Oh geez, that fuse replacement guide. Yeah, I think, well, so I've got a clamp on current meter, which I think should be just right for this. I need a bigger screwdriver. Oh. Well, ironically, I needed a screwdriver with a bigger tip, but maybe not actually a bigger screwdriver. This one is actually a pretty good fit. So line, neutral, ground. Using these weird American wire colors. Oh, are these gonna be too long? Yeah, and I'll see what kind of caps I have handy that might help smooth this out in case that becomes a problem. Yeah, these are too long. Let's carefully cut these to avoid conductive debris everywhere. All that conductive debris. Whew, there's still some on my tool. That stuff is nasty when it gets in your circuits. Yeah, I'm a little concerned about that each winch bot might just need a massive power supply, but I mean, each one, you know, I guess I shouldn't really be thinking about stall current because that's not really where I'm going here. I want the robot to be operating the motors at a pretty reasonable load most of the time. But I do need to worry about if the voltage drops too much, it'll just reset my microcontroller, which isn't going to be nice. I guess that might be one reason to use a power supply with a separate 5 volt and 24 volt output. So the winch bots run on 24 volts, but the flying part of the Tuco Flyer runs on 12 volts. Since it needs a lot less power, it's just powering the gimbal and the camera. So it needs maybe an amp or 2 amps. The power supply I'm using for it is rated at like 4 amps, to be conservative there. Okay, so I've got a plug. I've got some exposed mains. Let's put a little bit of capstan over that just in case the cat jumps and lands on those terminals. So, a little bit of assurance. So we've got minus and plus. Let me look for electrolytics. Well, I've got 2200 mic at 16 volts, which doesn't do us any good. I've got some photo flash capacitors, which probably aren't what we want either. I've got some 220 mic at 50 volts, which might help, but I mean, I'd be surprised if this power supply doesn't already have more than that on the outputs. I see 35 volts. What is that rating? I'm trying to read the output caps that are already on this power supply. "35 volts, 470 microfarads. Let's see if I can beat that. That'll require a bigger bin. That much better. I mean, I think I could technically take a couple of those 2200 mic 16 volts and put them in series, but that seems like I don't want to get a face full of electrolyte today. So maybe let's not do it that way. Let's just try to test this kind of gently. I'm going to try to power this motor up, not put it under that much load, then kind of add some friction and just see what the clamp meter says. So let's mount a wheel on this motor and then put the motor itself in a vise. Where's the vise? There we go. Alright, that should be a pretty nice grip. That's the cast aluminum housing. That's stuck down to my mat mostly, but it'll be enough, I think. And then let's find a somewhat assembled, well, none of these new style ones, the ones that actually fit the gimbal the ones that fit the motor are glued together. So I'm just going to use one that isn't assembled at all. So this is just the bottom half of the spool, but it has the right size hole once I remove the printing debris. Okay, so this just takes a set screw and then we can mount it on the motor. Let me grab the M3 hardware. Hey Tuco, what's up? I'm pretty sure Tuco does not like M3 hardware, which is good because he'd probably have a hard time not eating it. Here's some. A little bolt. Meow. So the nut slides in there. Bolt slides in there. And then I grab the wrench from the other box. Is this the dark green wrench? No. I think it's the light green wrench. 2.5 millimeters. Yeah. Okay. So that's biting into the nut we have there, I think. Oh, no, not quite. There we go. So, you can see we've got a captive nut assembly. And then we can bite into the D shaft on the motor a little bit. I'm going to back that out, and then we can install it for testing. Make sure this power supply is on the right. Oh, it isn't. They ship it set to 230 volts, and there's a switch. So it is not universal, it's selectable. That's right. There is a universal version, but I cheaped out on this project since there was some selectable stuff elsewhere, so I just made the whole thing selectable. Just a little bit silly, but that's what I did at the time. So that's on 115 volts. Let's mount this on the motor. Okay. What do you want, Duke? I think we just need the clamp-on meter and to attach this to the power supply, and maybe a power switch I can use as an on-off. That is too small. Where's my little stubby giant screwdriver? Tuco, what do you want? Ow. What does the cat want? Okay. Maybe I can have my fluke over here measure voltage while I have the clamp-on meter do current. Tuco, what are you doing? And do I have something else here? Just wires with banana plugs on the end, maybe? Oh, this is kind of what I want. Some mini grabbers to banana. Kind of the cheapest possible harness, but it should do for measuring voltage. These, I'm just going to lightly screw these on. Alright, so multimeter measuring voltage. Let's get the clamp on. Okay, so for this I can clamp it on pretty much anywhere that I'm not going to expect a whole bunch of magnetic interference. So I should perhaps keep this away from the motor and the power supply to some extent. I think that's what I want. I think I just zeroed it to the reading it was having just then. So amps, volts, I think we just need a switch and to keep Tuco out of this while we have it on. Got a little power squid thing with a switch on it, which should do if I had a longer lead for it. The cables I need to make this more convenient are still in my disorganized mess over here. Let's use a couple of these. It's not quite what I prepared for in this video. Okay, so I've got a little on-off switch. It's currently off. I'm plugging it in. Let's just try this to make sure it starts up fine. So we have, let me see if I can get the camera position slightly better for this. Power supply, 2 meters. Tuco, stay out of this. All right, nothing obstructing the motor. Let's try it. 24 volts, 0.3 amps. Let's keep an eye on that startup current. Hey, Tuco, stay away from this. It didn't show much on the meter, but that doesn't mean it didn't have much of an inrush. So, that is pretty hard to actually slow down. It just heats up my fingers before doing much else. It's pretty easy to get it up into the 2 amp range. I just saw it go to 2.6 amps. That's about as much as I can do safely with this setup, but I think maybe that tells me that the power supply I need might not be that much smaller than this big Meanwell that I'm using right now. Yeah, and as far as, I mean, some of this I can't necessarily test that scientifically without deciding on actual numbers for how much torque I want this to have during a normal operation. But, all right, well maybe we take that into consideration. Leave a decent amount of room in the winch spot for the power supply because it might need to be big, but then do more testing on this later once we have more of it built and we can get some real numbers under load. So, I think that's it for that. I will put away this power supply and we can do some CAD. Where's the cat? Oh man, I'm looking forward to a future with Tuco Flyer where I can have intermission segments where there's a automated / crowdsourced approach to getting some cat graphics while I generally get this next segment ready. I think I heard him in the kitchen. I'm not seeing him. Maybe he went upstairs. One thing we could also be doing is assembling these spools, since I've gotten several of them 3D printed. That would be kind of fun. Although, again, I'd like to mostly focus on CAD if we can. These motors are pretty nice and powerful. Okay, let's keep this nearby. Get out of the way. There's like a frame of the previous view from that camera. A halftime show. Yeah, that'd be funny. Okay, so we've got some parts. I know, you have multiple files. How do I get that to go away? Alright. So, we've been looking at the spool, motor driver. We've had several, oh, there's Tuco. We've had several previous streams where we've been paying attention to the pulleys and capstans and generally things that roll. We've got a lot of that stuff in pretty good shape now. So this is the encoder, which is going to be measuring the progress of the string as we're pulling it. So this is the main feedback mechanism, whereas the with the DC motor we can kind of put some power into it, and we have a vague idea of maybe how much to expect it to move afterwards. But mostly we're using this, which will have the nylon cord pressed up against it by a little bit of kind of lateral pressure, and it'll use that to get its kind of primary feedback about how much the motors have actually accomplished moving the thing that they're trying to move. So one of the weird design features here was this kind of sideways set screw, which was to avoid having a set screw in this working surface, and that actually seems to be doing pretty well. This was the prototype there. It's a little bit wobbly, but that's totally, like if you just look at the running surface that we're going to be using, that doesn't move very much and it'll be fine for our uses, I think. So we got that. Got several more of these that I've been 3D printing. You can see this just prints on the base of it and has a little bit of support holding the top up, but then the actual running surface stays pretty clean. A little bit of support in there. I've also got a bunch of these little idler pulleys. So these are all the same. They all come off the 3D printing with a little bit of support. And then these are pretty nice. They have a smooth running surface. They have a bit of a lip on either side to keep the cord on there in case there's any lateral tension that we have to deal with. But they're designed for situations where you aren't really expecting lateral tension, so that's just for, mainly the ridge is there to make this easier to wind when you're getting it set up, I think. So then here we have space for a 606 skate bearing, and then just an opening that's big enough to pretty easily clear an M6 bolt. So for these, I printed several of these, and the way these work, I give the inside just a light scraping to make sure we have a smooth surface that we're dealing with. What tool was I using for that? Maybe I did that really lightly with a knife. So this just removes any 3D printing artifacts that make that surface bumpy, which could make the next step annoying. Feels fine. A little bit of debris. So then this actually has several features 3D printed into it. It has a ridge on top that holds the bearing in once it's fully seated. It has a kind of a feature with an undercut there that gives room for the corner, but actually holds the bearing where it needs support. Oh yeah, Mike in the chat asks about an optical mouse sensor to look at the cord. That's an interesting idea. I think there might be problems with the overall accuracy of that, but the biggest problem is just that we couldn't really find much of a source for those. It used to be you could get them on DigiKey, and it used to be you could get them from Microchip, but as far as recent sensors, we haven't really been able to find good sources. So that, I think, was where we got hung up there. So then that's prepared. Then we take a press, tube of cheap bearings, bearing on the press, Physics Dude asks, how much of a tolerance do you include in your 3D designs to, for example, allow that pulley to fit snugly on the D shaft? That's a really good question. It depends a lot on what I'm trying to do, and that one was actually the result of a bit of trial and error because I wanted pretty much all of the slop in that fit to be in the part of it that is not dimensionally critical. So I tried to design the hole there so that at that meeting point at the bottom of the shaft where I was kind of pinching it by, that was dead on, but then around it, I think I had a total of about an extra 1/4 millimeter of radius to allow the fit. Which is, I mean, a 1/4 millimeter is kind of a number that I generally reach for when designing tolerances for this kind of 3D printing, but it varies a lot depending on what you're doing, so there's certainly some trial and error. Tuco, you're so in the way, but how could I ask you to leave? What are you biting? Oh, Tuco, that's wire. Don't eat the wire. That is like really thin bus wire that he's batting at. I know it's interesting. Hey, Duke, stop that. Hey, hey. Tuco, what are you into over there? I want you to be careful, there's some sharp things. Yeah. Usually in these moments where it'd be great to throw a bolt quickly and distract him, as Sodium is suggesting, I don't actually have a bolt on me because he just... I guess I just need to order more of them from McMaster. He just is so great at disappearing them. Mikey asks if Tuco has toys other than bolts. Kind of. He's so much more into the bolts than anything else I've tried with him. Alright. Cat intermission. So bearing press. This just kind of aligns the bearing and presses it by the perimeter. If you look at the features, we designed this on an earlier stream as a really quick CAD project. So it's got a little nub that holds the bearing. It's got a ring around the edge that actually presses it, and then just an undercut in the middle to give room for the spinning part. And then the whole thing is a little bit narrower than the bearing itself to allow it to fit in tight spots. So then the idea is you kind of line this up with the hole. Let's see if I can get this on film. I didn't photograph the last few of these I did. Not quite sure how I can do it, but let's try. So I think it was, oh, focus. Are we gonna need manual focus for this? You can see it's not very even. But because the plastic is kind of flexible, it doesn't need to be that even in my experience. But this is maybe too crooked. Let me try that again. That's part way in. You can see that it's pressed in, but it isn't actually over all of the bumps that it needs to get over. So then more pressing. That's, I think, fully in. Bearing is fully seated right under those little ridges that grab it on the inside. So it's pressed tightly between this top and the bottom. So now it's just like these. And so with either of these, if we take an M6 bolt, which I've got one right here. Oh yeah, I designed this bearing press so that I could use it either by hand or with the vise, but I kind of like using it by hand. You get a lot of control over it and it's kind of fun. But yeah, I designed it with a flat surface so that you could squish it if the thing that you're pressing into also has a flat surface. So then these, that goes in there. Pretty good idler. And then in a completed design, you would have another plastic boss that this would press into probably and it would hold the bolt in. But for now, I can just put another bolt directly on here. So then rotates as nicely as these cheap bearings allow, I think. Yeah. I mean, the grease in there is going to apply a little bit of resistance, but it should be smooth, and it feels pretty smooth so far. So that's what we got. So I think that just leaves this piece, which is pretty much the same idea, but much bigger. These are the small idlers, and these are the wider idlers. And so the process of converting a small idler into a wide idler has been wider idlerizing it, which was actually pretty fun. And this is actually pretty single purpose. This is just used for this is the last idler before we actually wind the spool. And I was just trying to keep the cord centered in this plane we're going to be working with, even though on the spool it's going to be wobbling side to side a bunch. And this is built the same way, it just kind of has more plastic on the top and bottom, but the actual bearing is in there, and there's a slope so that the support plastic can come up there and actually act as kind of a cantilever support for the bolt. And this actually spins pretty well without much wobble. And the bearing is right under the central plane where the cord is mostly going to be riding. So even though it will support the cord riding up here, it's designed to be strongest when it's right in the middle, which is also where it tries to keep the cord. So I think that's all the little pieces. Oh, let's assemble some of these while we're assembling things. So we also have this. This is actually maybe my most fully assembled of the second gen. I guess I've got two that have bearings in them. So these two, you can see that I have two halves for a spool. This one already has a set screw in it too. And I've cleaned out this hole a little bit. And they're fitting together pretty nicely, even though they're not actually glued yet, but they're still holding pretty parallel like this. So part of what I was worried about here is, for example, if I take these two that are not assembled yet, you can see one of these, this is the idler half, which has a place for the idler boss to mount. This still has brim on it. Oh, maybe I want servo AF back. So here's the idler half, which just has this curve and that curve. This is the drive half, which is a bit more complicated. Robert says I need to start adding various traceability markings to my 3D prints. Like what? Are you talking about like a barcode or something? I mean, part of the challenge there is like printing text on it is totally a thing you can do, but usually I just don't want to waste the time on it because it does add extra design and manufacturing time. And like if there's some way to internally embed a version number or like a Git revision or something into the print, then maybe that would be interesting, but it's not something I care that much about. I mean, I know these parts from each other pretty well, but I can see that being useful in situations where the differences get more subtle. So this is the drive half. It has a hole all the way through where the cord can get tied off. It has the set screw on this side. It has a much more obvious place for the bearing to go here. But actually, if you look at both of these halves, both halves have a spot for the bearing to mount. This one is much more subtle, but there's a small flat on this inside that can just grab the bearing a little bit. So these will assemble together, and they kind of fit together into a spool, but there really isn't any rigidity here. So I was concerned that while gluing these together, it would be really hard to line them up just right. I would need some other jig to keep them flat, and I would worry about that coming loose pretty easily. But then I realized just via the overlap that I wanted anyway for structural coherence, for like both halves to have their own structural attachment to the bearing, that also made it pretty easy to anchor them. So these aren't glued yet. These are just both pressed onto the bearing. So let's try to get this other one to the same stage and then maybe glue a couple of them. This is pretty nice. This isn't, like, it's not that strong. I could easily pull this apart, but it's lined up really nicely because they're both pressed onto the bearing. And then the idea is I could just seep a little bit of glue into the edge, which is probably what we'll do next. So I have two of these in that state. I have parts for two more. So these, some of these are fresh off the printer. Whoa. There's actually a big difference in print quality between these two. These are before and after a nozzle upgrade on the printer. So this was before. You can see the print is pretty dull on the surface. And then this is with the new nozzle. The print is really shiny. So I wonder if that's just surface finish on the nozzle itself. Mikey says, that's a big spool. Worked out what kind of cord you're going to use? Well, yeah. The spool size came from a spreadsheet where I worked out the dimensions of the room I wanted it to fly in and the cord volume, and I tried compressing the cord about the amount I thought it would be and tried to get a good estimate and then leave some extra, and so some calculations went into this. It's probably still bigger than necessary intentionally, but there's going to be plenty of cord for having the flyer address pretty much all parts of this room, so that meant having a large-ish spool. Graphy asks, is it PLA or ABS? All of these prints so far are, well, yeah, all of these are PLA. I was experimenting with printing these in PET instead because it's structurally pretty nice for this sort of thing. But yeah, I was having trouble with the PET warping, I think was the problem I ran into. Well, I can clean up the edges of these prints later. I don't really care about doing that all right now. So, here's one spool, pretty much fresh off the printer, just with a little bit of brim cleanup. So I'm just going to lightly scrape out the insides just to make sure that there aren't any obvious bumps still. And then bearing. You can see this fits in there kind of tightly, but I might have to scrape it more actually, but let's take a look. Let's try to get the side angle again. Oh yeah, Mike says that a possible issue is that the cord under tension will dig down into lower layers of cord wound around the spool. That is definitely an issue that I've been running into in my testing so far. I'm expecting that I might not have to worry about it as much when the tension on the cord is more consistent than just like holding it by hand as the motor runs at random speeds. But that's definitely one of the early things I'm going to have to test once I get this winch bot more assembled to see if that's a problem, since it definitely could be. I think that needs a little more scraping out. It's a little too tight. I can imagine a more complicated sort of winding system where the cord, or or whatever I'm using, has to follow a particular spiral path, rather than just kind of haphazardly bunching up. All right, I think that clicked into place. So then, this one, similar deal, just a light scraping to make sure I don't have totally irregular stuff there. But it's mostly just straight out of the printer. Whoops. That bumped the bearing out on the bottom side. There we go. It's clicked back in. Yeah, I'm wondering, how did I do this part last time? A vise would be the obvious answer. I just don't have a vise big enough. That is also a little bit crooked. It being crooked seems difficult to accomplish. had something pretty solid on top of this last time I did it. It was just really hard to film that way. Let's see if I can get a better angle with the camera anyway. I might have to move this camera clamp totally way down on this pole. Let's try that. Oh, Tuco's sitting right next to me now. I should get that on camera too. Oh, if vise isn't big enough, how about a bolt and a couple of big washers? I don't know if I have any washers that big. Wow, that would require... Because like the washer would have to be that wide. But I think I just need, I think I was using some metal pieces to help out with this last time. Let me just try to be a little more methodical about this. Maybe time to shorten the legs on the Tuco tripod. That needs a little bit more scraping. Now I get plastic shavings in the bearing. Maybe this thing that I was trying to show off is actually a terrible idea. Actually, I wonder if I pressed this bearing in further than I did on the other two somehow. It still feels like there's enough to grab onto though, like I just need to actually give this the right kind of pressure. Let's move the camera down a little more. Mike used to just hammer. I would do that if I wasn't trying to film this, but hammer will shake everything on this desk. This desk isn't really something I can hammer on. And I can hammer on the floor, but if I hammer on the floor, then I can't get the camera low enough. It might be just this is something I can't film, and I just have to do it off camera again, because I know I don't remember it being this hard to do it off camera, but I don't remember exactly what I did differently. Maybe I had to do it the other way around. Let's see if that is any easier. Oh, maybe I stick to the CAD and figure out how to... a big G clamp or similar. Oh, I have a C clamp. Huh. This one has a messed up rivet on the end that holds in the little presser bit so it can easily fall off. So that would work on one side. Maybe we can make this work. We want this on this side. This kind of on this side. It has to be much further in. This clamp is... that part's gonna fall off. I don't have an easy way of really centering the force this way. Oh man, this camera positioning is pretty bad. I really need a plate to put under this side here. Oh, that's so annoying. I'm just gonna tape that on. That's really hack. Mike says, use clamp with metal plates. It sounds like an adventure game input. Like everyone else is just telling me how to do this, and I just have to follow the commands and then fall off cliffs and award points and that kind of thing. All right. I probably need another plate on top. I just don't really have a good way of supporting a plate like that without it falling easily. don't remember it being this hard to get it in the first time. This does feel like it is not, like just with more pressure that this would work, or possibly more scraping. Maybe I am underestimating how much scraping was necessary last time. This thing still came off. Oh, is that doing better? Thanks, scraping. That might have been it. It might just be really easy with the right amount of scraping. Let's not be servo AF. I don't trust it to know what to focus on. Can we do that? Oh yeah, I think that feels like it's kind of locked into place. That's how it's supposed to go. It's a very subtle press fit. But once it's on there, you can see it's, well, if I would actually angle that right with the camera, you can see that it self-aligns pretty nicely. Let's see if we can reproduce that with one more of these. So there's the through hole. There's the set screw hole. And the seam should be even all the way around. Okay. It's a little harder than I expected it to be, but then, so on this side you can see the bearing presses into that little lip that we were scraping a little bit. And on the other side it's, embedded inside. And if you were to do a cross section, it would be right here in the middle, just a little bit above the seam. So this is ready for some glue. Let's try to press the last one. We have 3 that are ready for glue and 1 that needs pressing still. There's the 3 that are ready. This is the shiny one that was printed with the new nozzle. So I think on this side I need to scrape it enough to kind of remove the printing cobwebs, and then just a little bit more. And then the one on the right, I think I kind of need to scrape somewhat more than I think is reasonable. Let's get the gunk out of there. Alright, let's start there and see where we are. I imagine it's pretty easy to over-scrape that and then just end up with no stiction at all. One more bearing for the little hand bearing press. And then we have... Let me get a better view. This needs to be opened up a little more. like the fine adjustment knob, but you print it and then you do the fine adjustment with the X-Acto knife afterwards. I kind of don't like that though. I always like models that are really close to usable as soon as printing, but stuff like this, even after some iteration, is really hard to get dead on. Of course, I still like trying. Maybe a little more. Some of what I'm doing is removing the kind of bumpiness that results from, I think, just from wobble in the belts on my 3D printer, leaving circles slightly wiggly. Trying not to get it to go in one side first. Is that in? It seems like it could go further in. Ow. Yes, apparently it can. It can also break off the end of my bearing press tool. So that makes it slightly harder to line up. That is not lined up right. And it took a little bit out of my finger. I guess I need to print a new bearing press. Okay. Maybe I print a new bearing press before moving on too much with this, because I don't want to mess up this bearing by pressing it from the wrong place. Let's go ahead and get that printing while we're doing the next CAD. And then maybe we can do some gluing. Yeah, and the bearing press tool definitely could have been printed tougher. I was actually having trouble with my nozzle clogging when I printed with high infill, but I replaced the nozzle since that, so maybe I should reslice that model and print it with higher infill this time. Let's try that. Where did every other part of my UI go? Okay, I guess that was full screen. Oh, so this bearing press is actually a thing you can just download on Thingiverse now. Let me show that. I mean, if anyone else wants it, it might just be no good, but despite my difficulties with it just now, I've actually done a lot of successful bearing installs with this, and so far I've mostly liked it. Public domain, so you can mess with it however you like. All right, Kira. Oops. All right. Let's edit this a little bit. These are the default high strength settings, but I think I care more about shells and less about infill here. Robert says that bearing press tool looks like it should be pretty easy to turn on a lathe. Well, guess which tool I have and which tool I don't have. Oh, and then sodium linked to it. Thank you. Okay. So this measures the infill in terms of distance between fills. 1 millimeter is, I think, pretty small for what we want. Let me try 2.4. And then shell thickness, let me try doubling that. That's a lot of shells. Maybe not double. How about a solid 2 millimeter? Mesmerizing. Yeah, let's try that. Maybe a little bit closer infill. It'd be nice if I could concentrate the infill on the end piece there and then use less back in the rear of the part. That'd be a good feature for future slicers. Or maybe even current slicers that are just fancier than what I'm using right now. Let's try that. Do we have video for this printer? I've been having trouble with the camera on that printer lately. Let's, well, I think we might just have to deal with it not having a camera for a bit. Unless I can SSH in and fix it really quick. Come on, computer screen. There we go. Let's go back to the Mac where I have an SSH client that I like. No, I don't want to close that. I would have to look that up for my password manager. You know, I think that there's so much construction noise around here. I'm pretty sure that the reason I've started to print a bunch of the kind of winch spools and the capstans and the pulleys and all that is that those parts seem like pretty close to done, at least for this revision of the whole thing. So I think the next thing to look at in CAD will probably be the bracket that holds the measurement capstan and encoder and the and the load cell and all of that together, and just generally think about how things are positioned relative to each other. Octoprint. Yeah, I'd have to rummage for this more than I feel like right now. I think, can we use the analog camera instead? Let's see if this works. No, that isn't actually connected, sorry. My setup is still not quite to the point where I have my stuff together to make that easy. So I'm just gonna go check on the printer in person, but I'll be right back. Printing a beautiful little raft. So, okay, let's put this together later when we have better tools. Printer is printing just fine. I would like to go on with the CAD, but let's just go ahead and put some glue on these, since it'd be nice to see what these are like once the glue is dry. And that's not gonna happen unless we add some. So for this, I think I just want to use a little bit of super glue and to try to put it on pretty evenly. So just put it in the crack, in that seam, maybe even while this is spinning a little bit to see if that helps. Yeah, if anybody's curious about the Octoprint camera bug, whatever, like, I was just having some problem where I think the camera driver or some problem within MJPEG Streamer was using up a bunch of CPU and causing the printer to stall, or at least print very, very slowly. So I hadn't gotten to the bottom of that yet, so currently the camera was unplugged. So if we look at this, I'm just, putting a screwdriver through the middle. That's the seam that we want a little tiny bit of glue in. So I've got this very thin super glue. And the challenge here is going to be just not overdoing it, I think. Yeah, this is definitely super glue. This would be easier if I already had it connected to a speed-controlled motor, perhaps. I thought it was going to be overkill to actually get the motor connected just for this, but maybe that would be helpful. But I feel like I'm kind of committed to doing this at least some more before I leave it, just because I've already started. Well, I think I've got enough for it to hold together. Might need just a little more because I don't know if I was getting it all in a useful position, but let's leave this for just a sec and get a motor connected to a slightly lower voltage power supply. water, rice. Power supply leads. Let's stop floating the power supply above ground, maybe. I was doing that to solve a transient problem with the gimbal and my USB. That should no longer be a thing. Yeah. Carefully insert this. It's not that strong yet. I need to clean out this hole a little bit more. Okay. Now I can try to get the glue exactly where it needs to be. Maybe let's try to smooth that a little bit. Just a little bit of glue where it doesn't need to be. Okay, that should be fine. Let's see if we can do that 2 more times. And I'm thinking of, well, what is the safest way to let this dry? Because, super glue tends to run a lot and just get over everything. I think I want this to be drive side down so it doesn't try to run into the bearing, although I don't think it'll run into the bearing either way. I think this way it'll tend to run down these walls if it runs anywhere. But this maybe is a little bit safer, so I'll leave it that way to dry. Yep, similarly not so wobbly. Really tough to get the glue actually in the seam when I do it this way. Huh. Looks like this is dissolving some of the pigment from the plastic. That Q-tip is turning slightly red. Okay, let's do one more.
Now that I look at this one, I don't know, it's probably all plenty of glue. A little worried that it didn't get quite as deep in the seam as it needed to on that one. Oh, Tuco, stay away from this knife. And the super glue I'm about to put on this. Buddy. Watch out, Tuke. That's a bunch of wobble from not being seated on the motor especially well. That's better. I think doing it kind of counter to the rotation direction is nice because I'm kind of pushing a bead of glue along and getting it further into the crack. Because that seemed to take a lot less glue to actually get it into the crack than the last time I did it. Yeah, the motor helps a lot. All right. Cool. So we have 3 freshly glued spools. I'll put these somewhere relatively safe. Back into the computer instead of doing all this real world stuff. I haven't been following too closely, but it looks like there's a little bit of discussion of next generation slicers and having like parametric geometry created and stuff like that. And that's something I'm interested in, haven't really experimented much with, but one thing that I wanted to try, I do like Rhino as far as, or Rhino and Grasshopper as far as kind of an interactive programmatic environment for creating geometry. And there's an extension to that for creating 3D printer G-code directly called Silkworm. It's kind of like squirting out filament by computer control. So stuff like that seemed interesting. Frameworks to make it a little easier to just kind of play with the geometry behind 3D printing without creating STL files first. Right, that was the one that I couldn't find anyway, so, or rather, it's somewhere in my password manager. We want the Windows. Windows computer, hello. There we go. Pronter is pronting. Ubec is ubecking. You sure are grinding stuff outside. Okay, so we've got quite an assortment of parts here already. Some of these are standard things like the 606 bearing and the LiDAR model that we got from the manufacturer. Some of these, like the shaft encoder, I made from sketches from eBay and then checked once I got the physical objects. We already printed a bunch of these parts, the little idlers and capstans and whatever. This is an entire assembly of the spool and the motor, which is pretty much complete too. So this assembly has the motor in there for reference, and then the spool itself is the two 3D printed pieces and the bearing and the hardware that holds it all together. Oh, cool. A link, Alex linked to Silkworm in the chat. Yeah, I haven't done much with Silkworm yet, but it seems really cool. I've been wanting to play with it. So you can see the internal mechanism here. So that's also pretty much done. We've got a lot of the gimbal parts. The gimbal project right now is on hold a little bit until I ended up needing a, well, it's a bit of a long story, and the noises and the sneezes are distracting me. Excuse me. But I ended up messing up the parameters on the gimbal after, well, very shortly before discovering how to read the parameters. I think I messed them up. And so I might be getting a new gimbal, courtesy of, I think, Mike in the chat. Not Mike for Mike's electric stuff, but a different Mike. I'm trying to remember their nick. I'm actually really bad at this. Oh, sorry, not Mike, Mark. I'm so bad with human things like names. But yes, Mark, WHI from the chat, contributing a spare gimbal for the CAT camera project. So that'll actually be here. What does the tracking say? Oh, it's actually in town. That's cool. So it might be here in the next couple days, actually. So the gimbal project is not quite even as blocked as I thought it might be. But we still have some CAD to do on the actual winch bots. And let's go back to that. We also have to write firmware for these things. I was planning on doing the firmware using these Tiva C microcontrollers, which you may have seen on this channel before if you followed any of the Sanrio Labs glitching that I was doing. These are the same processor. I just happened to use them here because they're actually a pretty economical way to get a microcontroller that is decent at doing things like motor drive and also has Ethernet. Because the idea with these is I want them to have a pretty low-level multi-drop network, so either Ethernet, where I'm just sending raw Ethernet or UDP packets, or RS-485, something along those lines to do the motor to robot communications. So yeah, this is what we're going to be programming, and this is what I'll be reserving some space for in the bot. Yeah, just for the folks at home, let's briefly look at Project Silkworm on the browser here, since I think it is pretty interesting. Yeah. This is a way for people who especially are more interested in using like visual tools than programmatic tools to create G-code for 3D printers that just does really strange things. And people are also using this along with, so like this is a 3D printer that prints in clay that they've been programming using Silkworm, and this is especially important because the individual threads that you're printing are so wide that you have a lot of opportunity to play with their particular layout to make interesting things. Yeah, 3D printed clay objects seem like a really interesting way of making, you know, like something that's potentially pretty durable, but also has something very contemporary about it. Since so much of contemporary technology is almost by definition transient, because it relies on this whole stack of stuff that no one's putting up the motivation to maintain indefinitely. So yeah, that seems pretty cool. Okay, so we've got this piece. I think this is where we're actually at. It's just kind of figuring out where things fit together at a high level with the mechanics in the winch bot. So this is missing a lot of pieces still. We have, let's go back to the other layout. We have the motor, we have the actual Fusion 360 is complaining that it's slow. Well, is that because I'm... No? I wasn't running OBS until now. Anyway, I don't know why Fusion's complaining. Tico. Did you want... You didn't want that one? Okay, so this plane kind of represents where most of my pulley cord hangout area is going to be. So the center of all of these pulleys and capstans are lined up with this plane. The idea behind this layout, I want the cord to come off of this spool at a fairly arbitrary angle, get centered by this idler, then there are a few things that need to happen here. So I want to measure the load on the cord. That's what this whole contraption's for. So this load cell measures the force in the direction of the arrow. I'm actually measuring the load on this idler. So the idea with that was the cord would pass under here parallel to the load cell. So the force on that part of the cord wouldn't be measured by the load cell. And then the cord exits this way, perpendicular to the load cell, exerting a force along the axis where this will actually measure it. So then the cord coming up to this point will, so it'll be running along this capstan, kind of taking an angle here, pushed kind of pushed against the capstan by this idler, and then it'll run around this edge, back across this idler, and then onto the winch, onto the take-up reel here. Yeah, Ryan in chat says, well, ever since getting into the 3D printing, the mantra has been, oh well, if you don't want the ridges, sand the hell out of it. But I'd love to work with the grain, as they say in woodworking. Yeah, I think that's a really good attitude. Making something where the actual 3D printing, because part of the reason why we see 3D printing is just like layer, 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 is because that's how we divide the prints up. But that isn't how machining always works. Machining is much more complicated because it's taking into account like what you can actually do with the machine without breaking it. But I think once slicer software gets a little more complicated and starts becoming a little bit more like modern CAM software, then we could start to see some really interesting tool paths happen. Microhex suggests acetone smoothing if you're using ABS, and yeah, that's the problem, is a lot of people really don't. I used to print ABS, but none of my current printers are set up for it. And then I use the epoxy coating for the VFD that's over on the rack, which I'm still editing a video about, but I should have that out at some point now that I'm back to doing the editing. And yeah, that was nice. It was a little bit nasty in that it puts off a lot of fumes, and you have to wait for it to set, and it's easy to get epoxy coating stuff you didn't want it to coat. But I think I'm kind of happy with this arrangement of idlers and capstans that I put together last time. I mean, it'd be nice to squish this together a little bit, because it seems like a little bit big right now. But I think we can do that incrementally as we actually start building the brackets that hold these things together and looking at what the actual requirements are going to be like. So, this is a good starting point. I think the next thing I was interested in doing is making something that attaches this idler to the end of the load cell. also concerned about how much working room it would take, as you're maintaining this thing, and if like the cord breaks or you're taking it apart or putting it back together and you need to thread the cord through it, how hard is it to get the cord through everywhere it needs to go? So part of this was I was concerned about, well, would I need to make something that I can just loop the cord around, or like a C-shaped bracket for this, or can I deal with something I actually have to thread the cord through, which is stronger but maybe harder to maintain. And I think in this case, I'm not going to expect to have to rethread this thing very frequently, and I think rethreading it probably does at least mean taking 1/2 of the clamshell cover apart. So I think I'm actually fine making this like a kind of an O-shaped bracket, something that supports it. I mean, even U-shaped, but O-shaped might even be stronger. So something that has bolt holes to attach here with, something that actually physically loops around this bar maybe. And then the critical dimension really just becomes, well, if I'm making that piece, how much room do I leave here to actually thread the cord through? And I don't think it needs to be much, but it also might depend on where the bolt holes for this go. Like, imagine I 3D print this bracket and the print bed is now horizontal. So each of these loops around the pulley and this bar can actually be made pretty strong. If I'm doing it that way, then the 3D printed part is actually acting as like a loop that holds most of the weight. So that's probably fine. And then the screws are to keep it in place, but they don't really have to be load bearing. And then I can just put screws in on this side where they aren't going to be getting in the way much, and they aren't kind of reducing this critical dimension. And then I can keep these as close together as I end up really wanting them to be for that, but just based on the opening I need for the cord. I don't have to leave room for screw heads also. So I'm liking that. The alternative would be to put the screw heads on this side, and then the plastic ends up kind of gripping the screw head and then this bolt, which actually isn't nearly as much strength, just because the plastic, you want to spread out the forces. You don't want to have force concentrations. And so being able to keep the force spread out to just grip this entire bar actually seems pretty strong. So that said, how much space do we want to leave for this? And can we break this up into parts that make this a little easier to assemble? Because I don't want to get into the situation where we just have everything being super, super interdependent. I guess we want to use joints in Fusion 360 for this too. I'm still new at using joints. I'm used to just moving parts into the position I want them to be in. So maybe the first thing to do is to get a reference position that's just midway between these two. And for that, that's kind of something I wish was already in this component. Maybe let's just put it in that component since we can cheat and do that. I don't know if there's maybe a cleaner way to do it, but I'm thinking I just add some construction geometry inside this component here. Do I already have sketches I can put this on? I'm just going to make some lines here and set them as construction geometry, but then we can use the midpoints for stuff later. In fact, I might just put points on there too. I always have trouble getting the points I want in the software, so adding additional reference points might be handy. So that'll be construction. Then I'm going to create some points in the middle. And that little icon with this triangle means that it's snapping to a midpoint and adding a constraint. So if you see that, then you're guaranteed that it'll stay as the midpoint. You can see the triangle there means it's got a constraint loaded. Let's do something similar on this sketch. Tuco, I feel your sharp toes on my toes. point. Point. Okay. That should have some more useful anchors for us, these points. So let's save that. Go back here. And now we have to update these nested components. That cat spends a lot of time in cleaning mode. Yay, now we have this thing. We also have a point up here that I think we can use. So let's try adding a joint. So we're selecting components, but I think we're also selecting points. Point. Okay, so now it's setting them equal to each other, which is not entirely what we want. Oh, geez, that's also moved. I don't really want it to move that. Can we start with this then? Yeah. I guess it moves component 1 toward component 2 to get the initial solution. But then I want to do an offset. Which of these axes are which? Is it Z? I think it's Y. No. I guess it's Z. Let's see what are, so 10 millimeters, I think. What is the offset that gives us no room at all for the chord? I think that was about 10 millimeters. Maybe 11, call it 11. Okay, and if we want enough room for this chord to be pretty easy to get through, I think we probably want 5 millimeters or so. So what is it like if we make this 16? That seems fine. I might add a little extra just to give it more room to clear the load cell there. Since the sensors glued to the load cell right there are pretty delicate and I don't want anything rubbing against them. About 18 millimeters. That seems fine. And that'll be easy to change later. Oh, I guess these two need a joint also. Doesn't everyone? So in this case, oh geez, so I need both. I need to attach the screw. I guess I need to attach the bearing to the pulley, or to the idler first. I thought that was something that was in the component I imported, so maybe that's something to put there. So I've got a component here for the bearings, but then the idler comes with its own bearing and bolt, so that's the proper place to put this. So I just need to add joints that force these to be where they are. You can get a closer view of those ridges that we were pressing against before. So this is the part that I printed that we pressed the bearing into using the DIY bearing press. These are little bumps for centering it, and these are bumps for retaining it. Let's take a look at how this interface works. Okay, so here's just the part. That's the center plane. Here's just the bearing. The main thing that orients this bearing should be this outer. Maybe we need maybe section analysis would help this actually. It's not the plane I wanted. I think the joint I want is from this edge of the bearing, or so like, sorry, this circle on the bearing to the corresponding circle on the seating. Which maybe be easier to see if I moved everything apart, but I don't want to mess with that right now. I feel like it'd be really easy to get stuff in my history that I don't want. So joint from the center of this circle let's hide this temporarily. And we need this circle. And let's not have an offset this time. That looks good. This is a rigid joint, just fine. I might make it let the other joint spin, but this joint seems like it should be rigid. Now we have the screw. Similar deal here. I'm going to attach this circle on the screw. Oh, maybe we want a revolute joint for this. And then on the bearing that attaches to this circle. So that's, I guess, how it can spin. Okay. We can turn on the stuff we hid. Save this and update it in the other designs. Oh, I guess it's not just this though, the small idler, but the wider idler needs a similar treatment. And I guess the encoder capstan, but definitely the wider idler. Joint. Oh, we already had a joint there. Okay. I guess we had one joint. I guess we need another one though, between the bearing and this body. This one is not a revolute joint, this is a rigid joint. This bearing is not going to move in this press fit here. That looks right. It's a deep hole for accessing this screw. That's fine. Okay, plenty of stuff to update in this file. Can you do it? Ooh, nice. So I updated this with a joint. I think this might be attached to the wrong one, like the one that's not, the one that should be stationary. Or rather, the one that should be rotating rather than stationary. I mean, that's probably fine. I'm just using this to set the design of the bracket, really. This actually, this shouldn't probably even be a joint. So I'll probably replace this joint with the actual joints we're using to set this later, but that's just kind of to help me get the position. I don't know, I kind of still think this should have some more subcomponents in it. Like, I think this project is really complicated, and I want to do as little work in this project as possible. So I've already broken out a lot of these sub-assemblies. I think I want to try to make a sub-assembly that has the load cell and all of the mounting for that. So I wonder if I can break some of this out into another file easily. Maybe sell it or save it and then delete the stuff I don't want. Can I save a copy of this? I have to click on the piece of paper. Save as. Load cell idler assembly. So over here, I think I'm just going to delete a bunch of this. Yeah, I don't need this capstan thing. I do want that. I do want that. That was positioning. Don't care about that. That's the motor and spool. That's the wider idler. That's some construction plane I don't care about. I think that was supposed to be the wall, or like the edge of the enclosure. That's my temporary joint. What is this doing here? Okay, now just looking down here, you can see I don't have a lot going on. I've got this piece linked in, this piece linked in, positions, more positions, and my temporary joint. The first problem here, of course, is the M6 bolt is way too long. Like maybe as much as I appreciate that idler coming with its own bolt, I don't want it to in this particular case. Since I think in this application, I mean, it definitely wants a smaller bolt. It also doesn't even necessarily need a bolt there, although that would be a convenient way to keep the whole thing together. Let me see what kind of smaller M6s I have handy. I have some nice small ones, actually. Is this M6 by 15 or something like that? I think this is an M6 by 16. Or maybe 17, probably 16. M6 by 16. Oh yeah, MM1 in chat says you can also create components inside the current project. Yeah, I haven't quite got the hang of that. So part of this is me doing what I'm familiar with, and part of it is that it seems like I probably want this to be a separate file anyway. It seems a little easier to manage that way. Let's just delete this. Great. Do I have a bolt hiding in this one too? Let's delete that. Let's just not have bolts in these low-level models. I also eventually want to get this stuff mostly out of Autodesk and into GitHub, because I want this to be usable by other people, so... And I also just don't want it stored in their cloud thing. So I'll be exporting everything into STEP and IGES files and making a nice directory structure for them too. So some of this might be helpful for that. All right, let's get a more acceptable screw. Oops. M6 by 16 socket cap. All right. So roughly we want this kind of over here. I'm not really going to worry about this too much. I'm just going to add a joint in a sec. I'm also just imagining how mechanically each of these sides is going to be held. So I think the side that's on the left now can have a nut, potentially even captive in the plastic bracket that we're about to design. And then the right side might even just be held in by having kind of a collar around this bolt that kind of friction fits into the bracket we're designing. Let's just go ahead and start scribbling. I'm probably overthinking this. Let's make a construction plane. we want a plane at angle. This will be kind of the center of the bracket, I think. So we'll use that as a place for a sketch. We'll call this bracket outline. So I'm going to use, all right, and project some stuff, like this face. Some of that stuff. Some of that stuff. Some of that kind of okay stuff in the middle. Definitely this. Oh, and I guess we've already got some of that, but that definitely. I want to get a nut in here too, because I want to see how big they are. Oops, not that. Extreme strength. Why does this have no OK button? Or any selection for that? That's weird. I guess it's already inserted. Let me just join these two. I might just center this whole thing, but let's see what, because I'm a little concerned about where the plastic between this bolt and the nut and these pieces is going to mostly want to reside. Alright, so this bracket outline. We want some horizontals to represent where the bolt is going to be going through. I think I just want to make some horizontal lines first. So I'm just using the constraints to stick these new horizontal lines to the projected vertices here where we know the bolts are going to go through. So that's where we need to leave room for. We're also going to want some lines that start from these and go horizontally. This is where we're making room for the bolt head. Then we want to leave some room for this to be wobbling around on its mount and not hit anything. So for that, we might take these and offset them. I guess we have to offset them individually. So this is taking the side of the idler and adding a little bit of wiggle room, literally. It seems like we have a decent amount of space there too, so maybe something like... Oh, how much does a millimeter look? A millimeter of wiggle would be an awful lot right there, but we could be... What does a millimeter and a half look like? Yeah. Let's give that a go and use that for a reference. Millimeter and a half also, and maybe a reference on the top. Let's make a fake line here that goes across there, and then offset that. So you can kind of see what this is leading to. This is going to be open. This is going to be open space, but then I'm going to have some amount of plastic that just surrounds all of this. So this curve is going to become the interior. I think I want these to be curved. Oh, nice. That was a fillet between two existing lines. So that was from Sketch, fillet. I don't think there's a key combination for that. There is no horizontal constraint for this. Oh, right. Offsets don't actually imply constraints. This has a constraint. Why didn't this leave a constraint too? So here I'm just adding explicit distance constraints here, since I guess the offset didn't leave me with any. I can set the radius of the fillet. Yeah, okay. And these come with tangent constraints, which is nice. Oh, I lost an axis. Yeah, I think the fillet took off the constraint, because maybe it otherwise would have been over-constrained when I give it the fillet radius. Anyway, that looks fine so far. And then this joins... So actually, I should draw a similar keep-out area on the bottom, and then I'll figure out how to interface it to the wrapper around this part. So I wanted a 1.5. Does that really need to be 1.5? This is going to wobble less than the side-to-side wobble. Let's try making this 3/4 of a millimeter. That seems plenty. That's still plenty of room for the side-to-side. I should maybe make this smaller. Oh, let me catch up in chat. MM1 says the advantage of using components in one file is that you don't need to switch between separate files all the time. Separate files are still really useful when multiple people work on a project, not so much when you're the only one and want to iterate fast. I guess I'm still used to the strategy of just wanting to have a bunch of small separate files from the way I like to program. And I understand that there are dependencies to manage between those, but I'd kind of rather have those dependencies be more explicit and easier to share with people than have them be kind of bottled up inside one file, I think. But yeah, I'll keep in mind that that might be a better way to work. 0.75. Okay, so that did leave me with a distance constraint. And then if I do a sketch fillet, that definitely took away the distance constraint. So, oh, there's a warning over here behind the thing. Warning, constraints and/or dimensions were removed during. During and why? Looks like there's more text there. Oh, during operation, thanks. Why? Oh, man. I would have liked if it didn't. Or if it at least let me choose not to. It's asking for another radius. This will start as 1 millimeter. Now I've got to give it this constraint again. Okay, so I think I've got this fully constrained ring around the pulley that should give me the area that I want to keep free for it. In fact, maybe I want to keep this as a separate sketch, since now I'm just imagining revolving this around the axis would give me a really nice space for the pulley, even though that wasn't originally quite what I was planning on doing with this. I guess part of this depends on how I intend to put it all together. Like, do I want it to be two separate pieces that bolt together, or do I want it to be a single ring? I like the idea of it being a single ring, which means that maybe making it not be a revolving piece, but it being an extrusion makes it easier to assemble. So maybe I'll just keep on with this way of doing it. Alright, so that's that. Let's decide how thick the mounting should be. I've also got a similar thing down here where I have this box that I want to surround in plastic, and I want this to be a pretty tight fit. Well, not infinitely tight, so let's first maybe give it a little margin. Where are those showing up? Let's make a hole for this. Definitely not 1 millimeter. Let's try 0.1. And this should leave constraints. There's the constraint down there. This seems to be fully constrained. So now I want another one of these. This will actually be plastic thickness. So, and this is maybe a bit more of a guessing job. Like, how thick do I need this to be before it's, or for it to be strong enough? We could certainly make, or do tests and try to figure out how thick this needs to be, but I think the easiest thing to do now is just to guess, and if it needs to be thicker, then print another one. That warning wanted me to offset the original curve again, which I guess I could do. Is 3 millimeters like? 3 millimeters of plastic seems like it should be plenty strong enough for this. Maybe 2.5 even. 2.5 millimeters. Similar thing here. So then I want to make these edges a little nicer, so maybe I'll just go from there to the tangent. And then turn some of these into construction lines. Why is this no longer solid? Oh, right, because I needed these. Okay. Oh, I did not need this projected. The arrow. As useful as that might be to have it line up with the load cell, I don't think that part is going to be in the print. Oh, actually, yeah, this part did need to be solid. I think I just need to trim that. I'm not sure all the constraints I care about survived that, but it looks like the shape did. I kind of want to prevent these corners from getting really stressed out. So let's relieve these with circles. So now I've got that. I feel like that could be thicker. Where is my 2.5 or whatever constraint that sets this? Now I'm thinking about trying to make this thicker and looking for the constraint that actually set that. Oh, is it this? I think this little icon that is barely selectable is the constraint I'm looking for. This is trying to tell me something. Huh. There's a warning, but I'm not sure what it was referring to. I mean, this might also look stronger once I extrude it. I've got to remember that part. Let's see what this looks like extruded. Symmetrically. So I will have to make some allowances for the string exiting on top, I think. But that's fine. I think I just want to avoid this section of the load cell that's going to have stuff attached to it. $13.5. Maybe I shouldn't bother going further than the edge of the load cell at least. 13. Oh, that'll be fine. And then thinking about printing this, now I'm wondering if I can like enclose this anywhere else to help with strength. I could build in some of these corners here for strength, but then leave it open on this side, since this is where the cord actually comes out, and then I can insert the pulley on this side for assembly purposes. Let's try revolving that shape I said I wouldn't revolve earlier. This would be just this curve right here. How can I get just part of that? This will be bracket outline. Let's just make another sketch. I don't think I even started that sketch on the plane I meant to. Let's delete that sketch. That's the plane I care about. I just want this shape back. I'll just project it. Oh, that's not supposed to be there. Where's that coming from? Why do I keep end up in the wrong sketch? Come on, this is where I want to be. There we go. I just want to rename this. This can be Pulley Pocket. Oh, I need to cut this in the middle, otherwise it self-intersects. Right, let's try that. Let's just project this axis then. Now I've got these two halves and I can just revolve one of them. That's better. Great. That probably needs to be deeper. I don't want the string to rub on this like pretty much ever. This is the cutout where the string comes out. What are you warning me about? Seriously, compute failed? Failed to generate profile. Interesting. I don't think I want all of these. I was about to trim some of this. Oh, that seems better. That's what I was going for. The extrude here seems to be kind of broken. There we go. That seems fine. Oh. How did it come up with that shape? I kind of like it. Huh. I mean, it's smooth in all the places it needs to be smooth. It's probably not printable on its own, but maybe that's what supports are for. So then on this side, I want to kind of add kind of the opposite. I want to fill in some of this for strength. So actually, let's just take this pulley pocket sketch and extrude it again. Hide this thing again. That's filled in. Now, let's cut out a hole for the pulley again. Cool, so now there's a place to pull out the pulley entirely on this side, but there's still some more support on that side, and I need room for the cord to come out right here again. So that'll go there. I think I just want to... I think I just want to take some out of the middle of this, actually, just with like a rectangle. The lower limit will be this projected piece over here. So then I can draw a rectangle. It's one of those cases where I do actually want to set the midpoint of two lines equal to each other, I think. So I can use the midpoint constraint. Now this is free to be kind of whatever cut I want here. So the vertical doesn't really matter. The horizontal I can choose to be a comfortable width for the cord to go through. What? Why will this over constrain it? Oh, because this... That's not supposed to be there. Okay, now I can set this. That was an extra constraint that got there somehow. So for this, let's try 6.5. And let's just cut that. again, I don't want sharp edges, so let's try to fillet these so that they're not so sharp. And for printability, again, this is the base plate, so filleting this edge is maybe not so great, but filleting this edge should be fine. Well, let's try filleting the, or actually, can we chamfer this edge? Because that's better for printability. I can always chamfer it with a knife afterwards, but this seems easy to do. Modify, chamfer. Oh, I guess that would be the whole thing. Well, let's try not tangent chain. Ah, I think that's what I want. And then round these a little bit. Not that much. That's better. I just don't want the cord to be snagging on that stuff as it comes out that way. Okay, if we put the idler back in, it goes right there. It's got a good margin around all the moving parts here. I think we mostly just need to worry about fasteners now. I think the rest of this looks alright. So these were weird, weren't they? Weren't there smaller screws on the load side than the non-load side? Can we do that with measure? Was that right? Yeah, 4 millimeters. So those are M4 screws? Those are 5 millimeter. So I've got one of the load cells right here. Well, I've got a bunch of the load cells right here. This was one that I was playing with. And yeah, I think those are M4s and M5s, but let me just test them just to be sure, and then put some screws in. Well, things we had virtually. M5s on the base side. Yep. M4s on the load side. Cool. And so for M4s, I've got some M4 by 16s. That should be about right. Yeah, let's use these. These are just like Phillips head M4 by 16s. They will go through a little bit. Robert says, wow, these designs are quite hard to manufacture without 3D printing. Oh, the ones that I've been doing so far? I imagine so. I haven't been designing them to be made without 3D printing, really. this is M4 by 16. I don't know that I have any smaller M4s, but this is probably an okay size. This whole thing is threaded. Alright, so let's get some bolts. I mean, these aren't actually the same socket head screws. These are actually different, but I don't know if I care. M4. I mean, I think I would ideally assemble it with something like this. Oh, sorry. With these socket heads, this just isn't what I have handy. So M4 by 16. So I need 2 of these. Create copy. Let's join these. So, let's position the base of the screw head up against the hole here and then give it an offset. Why did that not do anything? Oh, that was a body? Why is that a body? I was expecting these to be components. How did I make that? None of the little history icons are highlighting either, so I don't know where this body came from. What? Oh, somehow I split my screw into 2 screws. Okay, back to 1 screw again. I think I might have done a copy bodies instead of copying the component, which is what I actually wanted. Copy component. I think that's what I wanted. Okay, I don't know why I didn't do that the first time. This is what I meant to do. I don't know why that joint's not working. That looks like it just selected the 2 points I wanted. Is it different if I use the other one? Do I have to select them in the other order, maybe? Why was that the case? I thought the first one was the one I was moving, not the other. Huh. Oh, that is the case. Yeah, I didn't want to move that. Is this fixed down somehow? Just making sure I can move these each by themselves as components and capture their position. Seems like I can. And I'm back in joint mode. I mean, I could try not using a joint, which is fine. This time I'm using the align tool. It's a little bit clumsy because then I have to go back and do the offset separately. Then I can move them together. Something like that. Four millimeters of bite there. So I do actually, I think, want to make some of this a little wider. Let's go back to the bracket outline. So where is the constraint that sets this offset? I thought it was... because it was based on this original curve. Is it this thing? These constraints are all so faint. And then I've highlighted it somehow, but I don't seem like I can edit it. I can double click it and it does nothing. I think these are the ones I want. I don't know how to edit these though. It's just like a tiny, tiny icon that just sits there to taunt me without anything I can do with it. Add offset dimension. Is that all I can do? Is that I can use that to summon a dimension that I can then use to change the actual offset? Where did it go? Ooh, is that it? 2.5. This has got to be such a special case. Can I make this bigger? Yeah. Just taking out that curve. This will just be a very subtle kink in the outline, but I don't think I care that much, and it will really not be noticeable with the plastic. I could fill it if I really care. Whoa. It's not dragging by my actual mouse. There we go. Huh, I can't make that constraint. Whoa. What happened there? I lost that constraint somehow. And this tangency constraint. How did I just lose constraints? That seems constrained. There we go. I think I would benefit from making this bottom specifically a little longer, just around where the screw heads are. And their construction rectangle. And this on the midpoint. I don't know why that constraint didn't take last time. So the height here is basically how much room we're saving for the area the screws are holding and the screw heads. Sure, 8 millimeters. Let's try 6. And then this could use a dimension too. Okay, that's a little chunkier. Another chamfer, because this is a really sharp edge right now that I don't really want. That seems like a job for a chamfer. error. Just having trouble with those ends. That's kind of a strange effect. Huh. That seems okay. It isn't like exactly what I want. Okay. Let's not worry too much about that. No, that's not what I wanted. That's more like what I wanted. Screw clearance holes, and now holes for the screw heads. I want to get the center here and then make another circle that's a little bigger. I guess I'm projecting that though. Seven and a half millimeter. Maybe I'll actually measure my screw heads. These are only 6.5 millimeters. Sure, 7 is fine. No, I didn't want that either. What? Hey, cat. I wasn't done with that sketch. Okay, so screws, load cell, nut. Yeah, we still need the bolt that holds that on, the actual idler. So the idler is kind of floating in there. I'm thinking about where exactly to put the screw. Kind of liking the idea where the attachment on one side is really just the collar around the screw head. Let's see what happens if we put the nut right up against one side of the bearing. How much room that leaves us for this whole assembly. I guess we want a line for that again. Is there a way to select multiple? Oh, I guess I already have the screw and that stuck together. Okay. Let's look at a section view, because I think that might be a little more instructive. So there's the bolt butting up against one side of the bearing. Or the nut, sorry. And so I could have a pretty snug plastic bit surrounding this nut that holds it in place and acts as a pretty solid anchor. Then on this side, I could have a plastic post. It wouldn't be able to fit all the way up in here though, because that would make the bearing or the idler really hard to get in and out. The plastic post could really only go as far as the edge of the bearing here. Which doesn't really help that much. Yeah, let's try closing this in all the way around the bearing and see what that looks like. Align. This. And this. I I guess I did stick that and the nut together. How did I do that? Oh, with a joint. Okay, let's get rid of that joint. I don't want either of these joints anymore. What? I thought I was going to use this as a temporary joint, and now deleting it is moving stuff. I guess we leave that one in for now. Let's remove this one that we were having trouble with just now. So that's one option. I don't like that very much. What I think would be better. I mean, moving the nut out for sure seems like it would be helpful. It's just that if any of the, so basically I need, the reason this design works with the idler sliding in the side and then the nut and the bolt going in is that those pieces are the only pieces that need to come closer than this edge. So the fact that I'm actually clamping the bearing center instead of just the edge of the idler that's accomplished by having a removable piece that's separate from a plastic enclosure. And like this would be doable. It would be the nut clamping on that side. I could have a little boss that comes up and holds the nut to some extent. I could have a similar thing with the screw on this side. It's a little annoying having the screw stick out on one side. I could also use a shorter M6. This is just what I have handy. To get this screw to not stick out, I would need to move the head over to the left, which means that something else would have to be this interface clamping around the bearing. Oh, you know what? I bet if... So this whole bearing, or the whole idler, can move leftward to taking up this kind of outline space during installation. So I could actually have, well, if that gutter space was a little larger than it is now, I think, I could have this so that you could take the whole bearing or the whole idler and move it kind of to, I guess, screen left to get it around a bump that I would put into the enclosure right here to hold the bearing. You might also be able to flex the enclosure enough to get it on. But I don't know, I kind of like this. I mean, you'd put the nut in before putting the idler in. You'd still have to get the nut. I don't think the nut can be here. What if I just align both of these to the edge of the housing? Yeah. What does that look like? So I could also put, like, I could just make washers, like a spacer that goes around the bearing in the middle here that has just the right shape. I mean, that wouldn't be enough. Like this is not a good interface. Like, I'm okay with that on one side where it's just kind of like sitting in there, but then there's nothing actually holding it side to side, which is not good. Let's try aligning this to that. And so with this, you kind of need a spacer. I think that's like, I don't like that. I'd rather just delete some of these. I kind of like that position. So there'd be like a collar that holds it here, basically. I could have a bit of a bump that comes in and grabs the screw a little bit more to stabilize it, but this keeps me from having to have a washer just right there, which I'd like to avoid. And then the nut could just have a spot to hang out on the other side of this, which I kind of like. Line. What's going on there? That's better. That's what I wanted. I think this is something we could work with. Maybe be a reason to make the wobble spacing that I had just a little bit wider, so that it's easy to put the bearing or to put the idler in, kind of offset, and then click it sideways to get it into the right position. So maybe let's go back and change that. How is this on the other? Failed to solve. Yeah, what's going on down here? Because this one just scooted over. Why won't this one do the same thing? If I undo this constraint, how can this move? Like that. Just make these equal. Okay. If I make this a bit bigger, 2.5. And where is this thickness coming from? Nowhere. I was trying to move these. I'm not sure if there's still a dimension constraint somewhere. Here's one. 4 millimeters. Can't tell if that's being applied evenly across this entire thing. Set that to 5. Did that not do anything? I think I just must have entered it wrong. I thought I would have been able to drag this point. What if I add a dimension? Is it going to complain? I just don't know where that's coming from. Apparently I'm already over-constrained. Other than my constraints being a mess, this is looking pretty good. Where? Well, I do have more horizontal room there. Just tidying up my sketches a little bit. This is the entry hole, the exit hole, the pulley pocket. Yeah. My current thinking is that with this current width, or maybe something slightly wider, it could go in around kind of a bump that I manufacture in on this side that actually does most of the holding. And then on this side, there's a much smaller bump that just does a little bit of additional holding for the screw head. When I make a sketch, I often expect it to prompt me for a plane, but then I don't notice that I already had something selected that it decides to use, and then I have to go back and delete the sketch. Yeah, actually, let's not do the nut yet. I want to do the other side because I've got a clearer idea of how that's going to work. Bolt head holder. That's too much. 2 millimeters. And I'm going to round it a little bit. So the middle one extrudes one direction. Oh, what about that middle? Yeah, that. Something like that to help hold the screw head. And then on this side, something kind of similar. Yeah, so over here, what plane do I want to make this on? That's fine. Just getting the sketch plane set to the same as the analysis plane there. So this, I'm going to make something that I can revolve. I think that's the easiest way to do it. Maybe not. Maybe I can just do 2 fillets like I did before. But let's try the revolve thing. I'm going to go between there. there's some bug where it's really easy for the space mouse to get kind of upside down when I'm in the sketch. I'm curious what the root cause of that might be. Also, oh, there's the reference line I wanted. Yeah, okay. I think we've got a shape there that we can revolve. I think it's joining that to the screw, which isn't what I wanted. Maybe a new body for now. Let's also cut out a space for that nut. And now I just need a center hole for that screw. Can I just extrude that? Maybe not. So you can see this is going to need to flex a little bit to go together. I'm not sure whether that's going to be a problem or not. So the nut hangs out kind of on the outside, but it's held in so that this will be easy to tighten. This plastic right here is providing kind of a cantilever support for the bolt, but the actual load is going to be mostly in the direction of this arrow, so that'll be taken up by, I feel like it's flashing every time I'm just trying to wiggle to point. There we go. So the load will be taken up by this piece of plastic here holding onto the bolt head, or sorry, onto the nut, by this piece holding onto the bolt head similarly, and by this kind of cantilever contraption. So I don't know, this might be difficult to set up, this might not be strong enough, but it seems worth a try. Let's also fillet this. And a tiny bit on this might make the nut easier to get in. 0.75. I can round all of these edges actually. And maybe some very subtle fillets on here to make it easier to get the load cell in and out. Hmm, 0.5 seems good for that. I thought I had a fillet here before that I messed up. Alright, let's check printability and maybe just give this to the printer and see, because I still don't know if this is going to be easy to put the idler in, but I think let's try the real object. I think it's getting to that point. Let's rename this too. Load cell idler bracket. Oh, I guess I should really name the bodies what I want them to show up in my STL files. I need to get a better naming scheme for these. Tuco flyer load cell idler bracket. Did I mess up again and type over the file that I wanted? Just can't make this easy. Oh, I think I should get something to eat and then work on some stuff that is not necessarily streaming. I need to get my DisplayPort mess sorted out with my editing machine so I can get back to editing and then do more editing. That's actually the right orientation already. Yeah, that seems fine. Some of that might print alright even without support, but the support will help it print better. And I don't know if I'm going to worry too much about making it super, super high infill or anything, since I don't think it'll need it necessarily, and it also might need a little bit of flex, at least for the current design. So let's just print it with defaults and see how it performs. It looks like that finished. Let's go retrieve it. I'm also missing my camera for the printer, which is something else that it's easier to fix when I'm not streaming. Alright, let's go check on the printer. Oh, our bearing press just printed just fine. That thing. So, I think I'm actually going to go change the printer color, since I want to print this in something other than red for contrast with the thing that's going inside. So I think this is about the wrap-up point. I might go in there and get the print started really quick, but I can't really bring you in there right now because of my camera situation. At least not easily. I guess I could try to do my screen sharing from my iPhone. Let's see if I can get that up really quick. All right, let's put some filament in the printer. I think that'll do for a while. All right, well, I think this wraps it up for the stream for now. We will get back to some CAD once we have this part printed and once I have a chance to take a break. But in the meantime, I'll be doing shop improvements and getting some video editing going and just all the usual stuff around here. Thanks for tuning in, folks. Happy hacking. See you all next time.